Bueno, muy buenas noches a todos, profesor, compañeros. El día de hoy les voy a presentar este artículo como el artículo número 4 del curso de seminario de investigación. Tenemos inversión completa de forma de onda basada en gradiente híbrido. Este es un artículo basado sobre inversiones, estabilidad de las inversiones, basado en el gradiente y en las optimizaciones. Y bueno, como ya está siendo de costumbre, vale, lo de inglés. Aparte de esto, quiero comentar que es un artículo muy actualizado desde el 20 de enero de este año, o sea que está reciente, o sea que tiene información muy nueva, muy actualizada y muy interesante. Entonces vamos a empezar con la lectura en inglés. Tenemos Tenemos full waveform inversion based on hybrid gradient. The abstract. The low wave number components in the gradient of full waveform inversion FWI play a vital role in the stability of the inversion. However, when FWI is implemented in some high frequencies in current models are not far away from the real velocity model. An excessive number of low wave number components in the gradient will also reduce the convergence rate and inversion accuracy. To solve this problem, this paper firstly derives a formula of scattering angle weighted gradient in FWI, then processes a hybrid gradient. The hybrid gradient combines the conventional gradient of FWI with the scattering angle weighted gradient in each inversion frequency, but based on the empirical formula derived hybrid. Using weighted hybrid mode, we can retain some low wave number components in the initial low frequency inversion to ensure the stability of inversion and use more high wave numbered components in the high frequency inversion to improve the convergence rate. The results of synthetic that experiment demonstrated then compare the conventional the FWI based on the proposed hybrid gradient can effectively reduce low wave number components in the gradient under the premise of ensuring inversion stability. It also greatly enhanced the convergence rate and inversion accuracy, especially in the deep part of the model. In the field, marine seismic data experiment also illustrates that the FWI based on hybrid gradient, the HGFWI has good stability and adaptability. Keywords, we have now the keywords. Some of those are full waveform inversion, hybrid gradient, scattering angle weighted, low wave number components. Okay, excuse me. Now we're going to continue with the first step, that is the introduction. The FWI method was proposed by Tarantola in the 1984. In the early 1980s, in this method, all waveform information in the simulated and observed data was used to construct the O2 norm objective function. And the gradient was calculated by adopting an adjoint state method using this optimization algorithm. The given initial velocity model was continuously updated iteratively according to the gradient in the high resolution versions. Result of the subsurface structure was obtained. Due to the potential of FWI to describe the velocity model of complex underground structures, this method has been widely discussed and has become a research hotspot in the field of geophysics. The gradient of FWI is usually calculated by applying cross correlation between the forward propagated wave file of sources and the back propagated wave file of residual records. The wave number components of the gradient is related to the frequency component of the data and the scattering angle between the shot and the receiver points. Thus, when FWI is implemented in some low frequency bands, numerous low wave number components that help avoid the cycle skipping of low frequency inversion are available in recent years. Many experts and scholars have studied the application of low wave numbers components in the gradient to reduce the dependence of FWI on initial velocity models. Apply large offset data to large scale structure because large offset data generally correspond to large scattering angle information. Uses scattering angle information to separate the low wave number and high wave number components in the gradient of FWI and increase the weight of the low wave number components to improve the inversion ability of large scale structure. Directly perform scattering angle filtering on the gradient of FWI and apply the large scattering angle low wave number information to close 108 crates to construct a highly accurate initial model. Based on this, combine such information with multiple scattering information to enrich the effective low wave number components, achieve the separation of demography and immigration components in the plane wave the domain, and verified the effectiveness and stability of the methods in file seismic data processing. The below hybrid multiscale FWI method based on frequency wave number filter, which improved the robustness of the multiscale inversion methods. Adopted demographic components from the gradient for inversion and obtained satisfactory experimental results in noisy and low frequency missing seismic data. Transform the gradient into the wave number domain. For filtering and extract the tomographic component using non-stationary smoothing. Propose a multiscale FWI method based on gradient decomposition in the wave number domain, which obtain a high precision initial model. Okay, we're going to continue with the next step, the second step. Let's see what we have. Now we have the second step, principle. The step number 2.1 is basic principle of FWI in the time domain. Now we have the objective function of FWI based on the L2 norm can be defined as we have E per V. That's equal to half of the symmetry of S with R due to the call of HR S less the ops due to HR with HS elevated to the T, excuse me. That's multiplied to the call due to HR with HS less the ops HR. Okay, that's the first function we have. Where W, where V denotes the velocity model, E of V represent the objective's function, HR signifies the receiver position, HS signifies the source position, the code denotes the simulated data. The OBS stands for the observed data. And the superscript T represent matrix transformation. Due to the ill-posed characteristic of the seismic inversion problem, the relative function shown in equation number one is difficult to formulate directly. And iterative gradient algorithms are often used to restore the velocity model. Here, excuse me, just one moment. Okay. Here we use the adjoint essay method to calculate the gradient and can obtain g of x g of x that's equal is the symmetry of SR with the multiplicating the integral of the fraction 2 of b of x elevated to 3 multiplicating alpha elevated to 2 multiplicating u of x t hs. That's up of alpha t elevated to 2. That's with the number lambda that's multiplicating x t x r with the derivative dt. Okay, we have where x represent the spatial position, g of x is the gradient, v of x denotes the velocity, u x t x s is forward propagated wave field perturbed by the source wavelet point xs, which can be calculated by forward modeling. Oh, that's lambda, the number lambda of HTHR is about propagated wave file perturbed by the residual record at point XR, which can be calculated by reverse line extrapolation. Then we use the conjugate gradient algorithm based on gradient precondition and express an updating process of velocity as a model as. For example, we have some equations here. We have mk plus 1 that's equal to mk plus alpha kjk and jk. Jk is equal to the first equation, qgk, k is equal to 1. Let's qgk plus beta kgk is 1, where k is bigger than 2, is major than 2. Where k represents the number of iteration, beta is the correction factor of the conjugate gradient, and j is the conjugated gradient. Alpha denotes the step length. Excuse me. And K and Q stands for the gradient preconditioning operator. Okay, we're gonna continue with the third step. The third step is hybrid gradient formula for FWI based on scattering angle weighted. We have the equation 2 indicates that the gradients of FWI is calculated from the cross correlation between the forward propagated wave file of source wavelet and the back propagated wave file of residual record. Those Al Khalifa in the 2015 and Zhao et al. In the 2020 indicated that the wave number components of the gradient are related to the frequency components of the data and the scattering angle between the shot and the receiver points. And wave number component can be expressed as K is equal to W of B cos, that's cosine cosine of theta up to theta up to of n, that multiplicates n, where k denotes the wave number, b is the velocity, the w denotes the angular frequency, and represents the unit vector of the wave number direction, and theta is the scattering angle. As shown in the figure number 1, the vectors n, s, and n are denotes the direction of the wave propagating from the source point of scattering point and the scattering point to receiver point. Respectively, the scattering angle theta is the opening angle between n, s, and nr. Now you can see the figure over here. We have the scattering point, this one. We have the scattering in the side n or in the side ns. So we have the number of this figure is a schematic description of scattering angle. Okay, now it's time. We're going to continue with a little conclusion. We have conclusion and prospect. This paper proposes a hybrid gradient which combines the conventional gradient of FWI with the scattering angle weighted gradient based on an empirical formula given in the study. The experimental result of Marmesi model revealed the following: the proposed method can preserve enough low number components, the gradient of in low frequency inversions, and reduce loss of low weight numbers components in high frequency inversions, which leads to a stable and high accuracy FWI with high convergence rate. Also, it has a higher inversion accuracy for deep structures. And the result of marine seismic data shows that our proposed method can adapt to FWI for field data well and obtain a high precision velocity model of the subsurface structure. Bueno, ahora ya finalizando el video, los 30 segundos en castellano, en español. Bueno, este artículo, como mencioné al principio, aborda el tema de las inversiones. Acá podemos ver que hay una serie de fórmulas que utilizan tanto derivadas como integrales, ecuaciones ya del estilo diferenciales, las cuales nos llevan a un análisis más profundo sobre el tema de las inversiones, sobre el tema del crecimiento exponencial de dicha inversión o de dicho logro que se espera se lleve a cabo con dicha inversión. Entonces acá vamos muy de la mano de los gradientes, de los decrecientes, las altas, todo ello. Y aparte de eso podemos ver que este artículo hizo énfasis en un proyecto real de la vida real, la cual fue un proyecto sísmico, pues un estudio de sismos que estaban dando en una parte de China más que todo, con el cual la hora de hacer esas inversiones la idea era eh, promover la infraestructura para poder reducir dichos sismos y aparte porque la ciudad lo resistiera. Y listo, ahí por medio de todas esas fórmulas se puede juntar pues como la información necesaria para poder uno analizar de manera integral y correcta todos estos temas de inversiones. Muchas gracias, feliz noche a todos.